Dear students, welcome you all to the course Fabric Manufacturing Technology. So in the last sessions we have discussed about the objectives of sizing, sizing ingredients such as primary ingredients, secondary ingredients. Okay, so under primary ingredients we have discussed about adhesives, softeners, the antiseptics, and in the secondary ingredients we have discussed about the list of like deliquescents, weighing agents, wetting agents, and bluing and brightening agents. Okay, so anti-foaming agents we have discussed under the category of secondary ingredients. So we have discussed in the previous sessions what are the functions of these particular ingredients and what are the examples of each and every category. Okay, and also we have seen that how the size paste is going to be prepared, what are the equipments involved in the preparation process of sizing, as well as the storage of size paste in the preparatory process or in the weaving preparatory process. Along with that, we have seen that for different kind of yarns or different types of yarns, what is the size recipe? Okay, so what is exactly the ingredients must be selected for particular type of yarn we have discussed in the previous sessions. So today we will discuss about the sizing machines. What are the sizing machines? How the size paste is going to be applied. Okay, and in that particularly we have a different type of sizing machines we have. So out of that we are going to discuss about 2-cylinder sizing machine and multi-cylinder sizing machine. Okay, so we will start the first one, that is 2-cylinder sizing machine. You can observe here the image is showing that the complete picture of how the warp is going to be flow, nothing but the passage of material through a sizing machine. So where we have different zones present in the cylinder or 2-cylinder sizing machine. So these are particularly, like you can observe here, this is called as a creel zone. Okay, where the warpers beams are going to be kept one beside the other. Okay, so that we will get number of ends required in the weaver's beam. As we discussed in the earlier section, like how we are going to calculate the number of ends in the beam or the weaver's beam, that is depends upon the number of ends required in the fabric. So we have considered that what is the fabric width and how many number of ends are present in 1 inch. So total number of ends present in the total fabric width we have calculated in the last session. So out of that, from the number of ends required for the fabric manufacturing, we are going to set the number of ends in each and every beam. Where you can observe specifically in the image, it is showing that there are number of beams in the creel zone. You can observe that the beam 1 up, beam 2 down, beam 3, beam 4, like that. There are several beams we have kept in the creel zone. So each and every beam is having n number of ends, particularly like depends upon the creel capacity. For example, if the creel capacity is having a 500, so nothing but in every beam 500 number of ends are going to be present in the each and every beam. For example, if we are, so in this image there are 6 number of beams. So each beam is having 500 ends, 500 ends parallelly. It was wound on the beam. So together, all 6 beams together, the total how many number of ends are going to be get? So 6 multiplied by 500 number of ends, that is total 3000 number of ends we are going to get from these 6 number of beams. Okay, so all these 600 number of ends are going to be passed through the sow box or size box, where exactly the size paste application is going to be done. Okay, so the size box nothing but where this sow box or size box, particularly we are going to pour the size paste in the sow box, and the warp sheet which is coming from the creel section is going to be passed through the rollers. So the sow box we will discuss particularly in the further slides. So through this sow box the warp sheet is going to be flow, or through the warp sheet it is going to be taken through the size box or sow box or in the size paste, so that the size paste is going to be applied onto the warp sheet. Whatever the size paste which is applied on the warp sheet is going to be available, so excess amount can be squeezed out into the trough of sow box. Then the wet warp sheet is going to be transferred to the drying zone for the drying of the warp sheet, because the size liquor is going to be applied into the warp sheet, so it should be dried, then only we can able to wind into the beam. Otherwise the wet warp sheet will not be winded into the beam. Okay, so if we are winded any wetness of the warp sheet into the beam, then there may be chances of damage of warp ends by the attack of bacteria or the fungal infections. Okay, so that is why we required to dry the warp sheet after the size application. So after the drying, the warp sheet is going to be winded into the beam. That is, finally we are going to get the sized weaver's beam in the headstock. So in the headstock there are several parts. So specifically, like after the drying, the warp sheet is going to be followed or passed through the splitting mechanism or splitting rods. So where exactly the warp sheet is going to be split, because the size paste nothing but the gummy substance is going to be applied onto the warp. So there may be chances of the ends are going to be get together, nothing but these warp ends after application of the size paste. So there may be chances of stickiness of ends in the warp sheet. So it should be divided by using the splitting mechanism. Okay, by using the splitting mechanism or splitting rods, we are dividing or individualizing the warp ends in the splitting zone. Then after the splitting, this warp sheet is going to be sent to the headstock exactly where the warp sheet is going to be wound into the weaver's beam. After the sizing, this weaver's beam is going to be transferred for the next section, that is called as post sizing operations, that is drawing in and denting. Then after drawing in and denting, the weaver's beam is going to send to the weaving machine. So this is how the exactly the 2-cylinder sizing machine is going to work. Now again I am repeating, what are the different zones present in the 2-cylinder sizing machine is creel zone, sow box zone, drying zone and headstock zone. There are 4 zones which are specifically we have in the sizing machine. Okay, so what are those? One is called as a creel zone, where the warpers beams are going to be kept, and together all the warpers beam we are going to pass parallelly into the sow box. Then we have a second zone, that is size application or sow box or sizing box, size box. So where exactly the size paste is going to be applied into the warp sheet. Then after that, the warp sheet is going to transfer to the drying zone. That is the third zone, that is drying zone. So the warp sheet is going to be dried. So excess amount of water or wetness is going to be dried off using the drying cylinders. Okay, and then this is going to be winded, the warp sheet is going to be winded into the weaver's beam in the headstock zone, where exactly the speed control mechanisms and total control systems are present in the headstock. Okay, so this is the overall picture of the 2-cylinder sizing machine is. So let us discuss about the each and every section. Okay, so before going to the each and every zone, just we will see that what is exactly the multi-cylinder sizing machine. 2-cylinder, why we are talking? Because there are 2 drying cylinders. One is big cylinder, one is small cylinder. Okay, so there are 2 drying cylinders to dry the wet warp sheet in the sizing machine. That is why the sizing machine named called as 2-cylinder sizing machine. And in case of multi-cylinder sizing machine, we have multiple drying cylinders. Multiple drying cylinders. So specifically 2-cylinder drying machine and multi-cylinder drying machines, what is the principle of or method of drying is? It is conduction method of drying. We will discuss what are the methods of drying in the further slides. So now you please see here. So what are the multi-cylinder drying machines consisting of? Same like what we have like in the CREEL section. So that is CREEL zone. After the CREEL zone we have a Sow Box, and after the Sow Box we have a drying zone. But you please compare with the 2-cylinder sizing machine with the multi-cylinder sizing machine. So in the 2-cylinder sizing machine we have only 2 drying cylinders, and instead of here we have multiple cylinders. You can observe that there are 7 different drying cylinders, multiple cylinders for drying the warp sheet. Okay, and after that we have a splitting zone and headstock. Everything is common. Only the change in between the 2-cylinder sizing machine and multi-cylinder sizing machine is only the number of cylinders for the drying of warp sheet is different. Okay, so this is the just simple comparison. What is the schematic diagram of multi-cylinder sizing machine is. Now there are advantages and drawbacks of 2-cylinder sizing machine and multi-cylinder sizing machine. So we will see small things or we will see small comparison, okay, in the further slides. So this is how the 2-cylinder sizing machine and multiple cylinder sizing machine is. Okay, and the working of these 2 machines are quite similar. Okay, and we will see what is exactly the different zones which are there in the 2-cylinder sizing machine or multi-cylinder sizing machine are. Okay, so most of the cases like nowadays all the MNC companies, they are using for the case of like multi-cylinder sizing machine in the weaving industries. Okay, so because there are some drawbacks in the 2-cylinder sizing machine, so all are following that, all are MNC, all companies, they are following the multi-cylinder sizing machine. Okay, so let us see that what are the different zones present in the sizing machine, what are the individual types are there. First we will see the CREEL zone. Okay, first we will see the CREEL zone. So this is also one of the multi-cylinder sizing machine. So where I have given 2 examples. One is having multi-cylinder, and where the warp sheet you can observe that from the CREEL, you can observe that there is a CREEL, and from the CREEL the warp sheet is divided into 2 sections. Okay, so there are 6 warp weavers beam and other 6 weavers beams are there, and these 6 together it is going to send to the single Sow Box. After the Sow Box, a particular sheet is going to be transferred into the separate cylinders. Like you can observe that 2 cylinders separate and 2 cylinders separate, and after that these 2 sheets combined together we are going to pass into the multiple cylinders. Again 6 cylinders are there where you can observe specifically, and after that the warp sheet is going to be sent to the headstock. And similarly, like in the case of like a bottom image also, we have split the warp sheet into 2 sheets. Why generally this splitting is going to be done, because you can observe that the number of warpers beams, that is number of warpers beam in the creel, if more number of warpers beams are there, that is nothing but simply the end density, number of ends per 1 inch, or number of ends required in the weaver's beam. If it is very high, like 10,000, 12,000 number of ends are required in one beam, in that case what we are following is we are going to split the warp sheet in the creel zone, and after the sow box we are going to split into two sections, and these two sections of warp sheet is going to be passed through the separate drying cylinders to efficient drying, for the purpose of efficient drying and for the purpose of efficient sizing. So sometimes what will happen, you can observe that the second image where the two sow boxes are there, two separate sow boxes are there. So the warp sheet 1 is going to be followed into the size box 1, and the warp sheet 2 is going to be followed or passed through the sow box 2, and both separately it is going to be dried and splitting can be done, and both together combinedly it is going to be wound into the one weaver's beam. Okay, so because of the more end density, because to get good quality of sizing or good quality of size application, we are going to use, or we are going to split the warp sheet into two layers, and after splitting into two layers, these warp sheets are separately, individually, which are going to be applied size paste and dried separately, then combinedly it is going to be wound into the weaver's beam. So this is how the different types of multi-cylinder sizing machines are. So depends upon the quality requirements, depends upon the type of fabric production, so the sizing machine requirements are going to be different. So generally, like the second case, vertical cylinder type or horizontal cylinder, multi-cylinder type are going to be there in the maximum most of the industries. Okay, so these are the things related to the two-cylinder sizing machine and multi-cylinder sizing machines. Let us look out of individual zones, that is, first one is sizing creels. Sizing creels or creel zone. So there are different types of creels which are using in the different sizing machines. Okay, there are different type of sizing creels which are using in the different type of sizing machines. So you can see here what are the different types of sizing creels are available. So you can see that the first one is called as over and under creel, vertical creels, inclined creels, and equi-tension creels. So you can observe that over and under creel, vertical creels, inclined creels, and equi-tension creels. These are the four categories generally used in the sizing machine. Okay, so let us look out what is the individual creel sections are, what is it consists and how it is looks like. You can see that there are beams. So the rollers which is shown in the figure is called as warpers beams. Warpers beams. Again and again I am telling, the warpers beams. These warpers beams are going to come from the direct warping machine. Warpers beams are going to produce in the direct warping machine. So these direct warping machine beams are called as warpers beams. Warpers beams are going to kept in the creel over and under, top side and bottom side, over and under creel. So why we are calling it as over and under creel? Because the beam arrangement in the creel zone, beam arrangement in the creel section is one is above, one is below. So that is why it is called as over and under creel. Now you can observe that the last beam warp ends are going to pass through the from the above the second beam, and both together, first beam and the second beam, warp sheets both together, it is going to be passed above the third one. Then 3 together, it is going to be passed above the fourth one, like that. So, for example, you can observe this image specifically here. Total 8 number of beams are there. So each beam is having 500 number of warp threads, and we have here total 8 number of warpers beam. So together all 8 beams, the final warp sheet which is coming or which is going to send to the Sow Box, the warp sheet is going to send to the Sow Box. Okay, so to the Sow Box is total 8 multiplied by 500. So total 4000 number of ends. This is for example. Okay, so if we have 12 number of beams, each beam is having 500, 12 into 5, 6000. If we have 14 number of beams, each beam is having 500 number of ends, 14 into 5, that is 7000 number of ends. So the number of ends required finally in the weaver's beam is directly going to affect on how many number of beams are required. So the number of beams are going to be calculated as per the number of ends required in the weaver's beam. So this is the calculation. And over and under creel, you can observe that one is above one and one is below. Okay, and there are few drawbacks of this. There are few drawbacks. That is like the warp sheet is going to be driven not positively. It is not positively driven because there is no driving mechanism, separate driving mechanism for the individual beams. So how this warp sheet is going to be delivered? Because the Sow Box is having a driving mechanism where the warp sheet is going to be pulled from the beams. So one above the other, that is the first one, and the second one is one above the other warp sheet of one is going to taken above the warp sheet or beam of 2, and these 2 together again we are taking above the third one. So there are so much of strain which is going to be applied into the warp sheet. Okay, so that is why this, by these drawbacks, there are again developments are being taken place in the creel sections. So the second creel type is called as vertical type of creel. Okay, and this is over and under creel, how the beams are going to be kept on the creel stand. So creel stand, nothing but it is like a metallic stand where you can mount the beam. Okay, where you can mount the beam, and the beam to beam, the axis is same in the throughout the creel section. Nothing but beam 1, beam 2. The axis of this beam, the flanges which are there in the beam, it should be followed into the second one, third one, like that. Then only your warp sheet is going to be taken into exact way. Otherwise what will happen? One beam you kept like this and one beam you kept other side. If you displace the beams, then you will not get uniform warp sheet in the weaver's beam. That is why the arrangement of beams in the creel is very, very important. Okay, and where you can see that there are bearings which are there to rotate the beam freely. Okay, so this is how the over and under creel is going to be looks. And the second category, that is vertical creel. So these vertical creels are classified into 2 categories. One is called as bottom withdrawal and the second one is called as a top withdrawal. You can see here in the particular image, I have shown that the bottom withdrawal of creel type, or the bottom withdrawal, nothing but the warp sheet is going to be taken into the bottom side of the creel zone. So that is why it is called as bottom withdrawal. We are withdrawing the warp sheet from the beam into the bottom side, then it is forwarding into the Sow Box. Okay, and you can see that vertical creel, how we can say that vertical creel? Because one above the other, exactly one above the other, we are keeping the beams so vertically, so that is why it is called as vertical creel. Okay. Once again I am repeating, vertical creels are two types. One is bottom withdrawal, second one is called as top withdrawal. In the top withdrawal case, warp sheet is going to be withdrawn from the beams to the top side and it is going to be forwarded into the sow box. And bottom withdrawal case, the warp sheet is going to be withdrawn from the beams to the bottom side of the creel zone and it will send to the sow box. Okay, so this is the thing, and where exactly you can observe that there are n number of beams kept on the creel. Vertically it was placed one above the other and the warp sheet is taking into the bottom side of the beams and it will send to the sow box zone. Okay, this is how the beams are going to be arranged in the vertical type of creel. Then you can observe here clear picture again, the vertical creels itself. So bottom withdrawal. So maximum cases the industries are going to be followed the bottom withdrawal, because the top withdrawal nothing but there is no there is again the fluff or accumulation, dust accumulation, and again it is at the top side. So the mounting or drawing of passing the warp sheet into the several rollers or guide rollers, it is somehow difficult. That is why what generally preferable is bottom withdrawal is preferable, and this is how the warp beams are going to be looks. Okay, and you can see that there is a beam creel, and like I told, like inclined creels are there. So inclined creels, you can observe that the creels which are present or beams which are placed in the creel zone like an inclination order. So slowly the beams are going to be inclined. Okay, so the beam 1 is having at low, beam 2 is somehow height 3, 4, 5 like that in an angle, that is in an inclination angle. These beams are going to be kept, and from the beams individually the warp sheets are going to be taken, and this creel stand and everything is common, and we have a driving mechanism for these type of creels. Separate drives like servo motor drives are present in the creels, so that the free rotation or the amount of warp should be withdrawn from the warpers beams are going to be maintained. Okay, so once again I am repeating, the delivery speed or delivery rate of warp sheet is going to be controlled by the servo motor drives. Okay, that is why we are using the separate driving mechanism or separate gear or separate servo motor drives to drive or withdraw the warp sheet from the beam. Then you can observe that how these beams are kept in inclination order. Okay, and you can see that the fourth category, that is EQUI-TENSION creels. EQUI-TENSION, equal tension. It is name itself. It is describing that EQUI-TENSION. Tension on the warp sheet is going to be maintained equally throughout the number of beams. If you use the first beam and at the last beam, it is there at the last side. So the last beam also going to control the tension. We can going to control the tension on the warp sheet when the withdrawal is happening. Okay, so because the distance from the beam 1 to the last beam is too far, so the EQUI-TENSION is the tension control will be very, very important, because if you are not control the tension on the withdrawal time, then what will happen? The stretch on the warp sheet is going to be increased. Stretch nothing but permanent deformation. Permanent deformation. Now for example, if the warp sheet is having 100 meters, if the warp sheet is having 100 meters, now for example, we are measuring in the creel zone itself. We are just taking the warp sheet and we are winding into one beam. We are not forwarding into the sow box or drying cylinders or eddy stop. Just we are taking several beams, we are converting into a one beam. Simple. Several beams are there, we are converting into a one beam. Okay. So you just see that there are 100 meters available in the warpers beam. Now these 100 meters of warp sheet, after winding into one beam, For example, if it becomes 101 meter, then what you can say? 100 meters becomes 101 meter. Nothing but 1 meter was increased. It is okay, na? But what is exactly happening is the yarn is stretched. Yarn was stretched 1%. 1% yarn was stretched. Stretched nothing but in the yarn cross section we have n number of fibers. Stretched nothing but the fibers are generally whenever you are applied the tension or strain on the wire, then what will happen? First it will elongate. After that, in the yarn structure, whatever the fibers are present, these fibers are going to slip within the yarn structure. After slippage, that is called as a slippage. So elongation if we have done, no problem. It can recover 80% or 90%. But stretch, it cannot be recovered to its original position. Okay. For example, if you have a rubber band, you stretch it, you just release it. Now the rubber band will come back to its original position because it is having 100% recovery. But in our textile materials, that too the yarns will not have 100% recovery. After stretch or after strain, if we are applied in the yarn, the permanent deformation in the length is going to be happened. So that is why you got 100 instead of 100 meters, you got 101 meter. That is 1% of stretch was occurred in the process. So that is why it is very important to maintain the tension in the creel zone to control the stretch percentage in the sizing machine. So this is the one of the simple example to control the tension. So equi-tension creels are nothing but individual rise again. So wherever the yarn withdrawal or warp withdrawal is happening, we are going to rotate the beams individually with the help of servo motors, and it is going to be transferred into the Sow Box. And where in the Sow Box also we have separate driving mechanisms so that there should not be any stretch occurred in the any zone. So these are the 4 different types of creels which are generally used in the Sow Box, generally used in the sizing machine. Now we'll go into the next section or next zone, that is Sow Box zone or size box zone. And you can see that image is consisting of the warp sheet which is coming from the creel zone, and it is going to be passed into the trough of size paste, or the trough is having, or the bath is having the immersion roller. So immersion roller, main function of this immersion roller is to immerse the warp sheet, nothing but to dip the warp sheet into the Sow Box, That is why we are using the immersion roller. If we are using the immersion roller, the warp sheet is going to be dipped into the warp size box or size paste, and after that the warp sheet is going to be passed into the Sow. In the Sow Box we have a squeezing rollers. So through the squeezing rollers the warp sheet is going to be passed. So what is the main function of these squeezing rollers are? To remove or to squeeze out the excess amount of size paste from the warp sheet. To excess amount of size paste we are going to squeeze it out by using the squeezing roller. We are removing the excess amount of size paste from the warp sheet, and it is still, these squeezing rollers are available in the trough only. So whatever the excess amount of size paste was squeezed, it is going to be remains in the Sow Box. After the squeezing, the warp sheet is going to send to the drying zone. Okay. So there are steam pipes in the Sow Box. Again, at the bottom side of the size box, we have steam pipes where the temperature can be controlled. So generally from the storage vessel, so the size paste is going to be transferred into the Sow Box through the pipelines by using the valves and the pump. Okay, so directly from the storage vessel, the size paste is going to be come to the sow box or feed into the sow box. So this size paste, if you keep without any giving the temperature, then what will happen? Again here also the size paste is going to be coolant and the film formation and the size paste becomes more viscous. So that is why what we have is we have a separate steaming pipes in the sow box. So continuously the steam, with the help of steam pipes, we are going to maintain the temperature in the sow box so that you can control the viscosity of the size paste. So if you control the viscosity of size paste, the size application or the size paste penetration into the warp ends are going to be effective. So that is why we are using these things, that is steam pipes, to control the temperature. And specifically you can see that there is a trough and there are steam pipes, there is an immersion roller and there is a guide roller and there are squeezing rollers where exactly the warp sheet is going to be squeezed. Excess amount of size paste is going to be removed from the warp sheet. After that the warp sheet is going to be sent to the drying zone. Okay, so this is the thing how exactly the size box is have. Now you can see that the simple diagrammatic representation where the warp sheet is coming from the creel zone and immersed with the help of immersion roller, and there are squeezing rollers where excess amount of size paste is going to be squeezed out and the warp sheet is going to send to the drying zone. And there are steam rollers or steam pipes are there in the inside of the sow box. So these are the different parts present in the sow box. Okay, and you can see that what is exactly the size box is having and how it looks like in the sizing machine. Okay, and these are the control measures or motors in the sow box and in the sizing area. And we have different types of size boxes are there. So where we have seen that you can observe that there is a one dip, nothing but one time we are immersing the warp sheet into the size paste and one time we are going to squeeze out. Okay, this is one type. So you can say this diagram one dip, one nip method, one dip and one nip method. One dip nothing but one time we are dipping the warp sheet into sow box, okay, or into the size paste, and one time we are squeezing out the excess amount of size paste from the warp sheet. So in the second category, that is two dip, two nip method, nothing but warp sheet is coming from the creel and it is immersed with the help of immersion roller 1, then squeezing roller pair 1, then immersion roller 2, squeezing roller set 2. So the two dip and two nip nothing but two times the warp sheet is going to be dipped in the size paste and two times it is going to be squeezed out. Because if you increase the dip and nip, that is two times you are dipping or immersing the warp sheet, two times you are squeezing out, so the maximum amount of nothing but the size paste can be penetrated inside the yarn structure, so the size pickup can be going to improve by using or by increasing the nip and dip. Okay, so immersion and the squeezing. Okay, so these are the two different methods of size box, and you can observe that there are different places or different parts in the sizing machine where you can see that the moisture roller, drying cylinders, as we will discuss in the further slides. So there are drying cylinders where you can control or where you can exactly evaporate the excess amount of water content or wetness from the warp sheet after sizing. Okay, and there are lees rods to split the warp sheet or into several layers so that any sticky ends are there or any sticky ends are there. So the sticky ends are going to be individualized. The ends are going to become individualized by the use of these lees rods. And you can see that there is a creel we have already discussed, and you can observe that there is a V creel or V reed where you can maintain the weaver's, that is warp sheet width. That is warp sheet width you can maintain. We can control, we can increase or decrease the warp sheet width by changing the V reed, by expanding or compressing the reed. So there is like, this is the reed for the control of ends. There is an expandable comb that is separate. So this reed is separate. So to separate the ends we are using. And there is a final beam. You can observe that the final beam, the warp sheet which was winded on the beam, that is sized weaver's beam. So now this beam is going to send to the next process, that is post sizing operations and weaving process. Okay. Then we will see the third zone. So till now what we have discussed is, we have discussed two zones. One is called as the CREEL zone and the Sow Box zone. Now the third zone, that is drying zone. Drying zone, where exactly the drying of or evaporation of wetness or water quantity from the warp sheet is going to be done. After size box, the wet sized warp sheet is going to transferred or sent to the drying cylinders or drying zone, where the excess amount of water content or wet is going to be dried. So you can see that the importance of drying. After getting squeezed through the squeezing roller, the warp contains normally about 90 to 140% of own weight of the wet size paste in it. Nothing but 90% to 140% of weight still it is there in the warp sheet. So that is why the drying is very important. So this sized wet warp sheet is going to be sent to the drying cylinders for the drying. So this is a very important operation, because the extent of drying has a great bearing on the physical properties of yarn, like strength, flexibility, brittleness and plasticity. So these are the parameters or important properties are going to be controlled in the drying process. Okay, so extent of drying, nothing but over drying. When we can say this is over drying, so when the moisture content of sized yarn is less than the moisture content of unsized yarn. So if we are measuring that moisture content of sized yarn and moisture content of unsized yarn, if the moisture content of sized yarn is less than the moisture content of unsized yarn, you can say that over drying was occurred. So over dried cotton yarns or warp sheet is weaker and less flexible and it becomes brittle. Okay, over drying if it is occurred, so after over drying the yarn becomes very brittleness and it is becoming weaker. So as well as the flexibility of yarn is going to be changed, because we are applying the size paste or size ingredients into the yarn. So now what will happen if it is over dried along with the yarn moisture content, whatever the size ingredients are there on the surface of the yarn as well as inside the yarn. So inside, nothing but there are air pockets inside the yarn structure. So inside the yarn structure also there are size ingredients. So the size ingredients are over dried, so it becomes very brittle. So the size ingredients are going to be over dried, so it becomes brittle. And as well as after over drying, the yarn quality in terms of appearance or color is going to be changed, like small like a whitish shade to a grayish shade. Okay, so over drying is occurred, nothing but the color of the warp sheet is going to be changed. Okay, and also over dried size film is more fragile and brittle and regain its normal moisture content as very slow rate. So over drying occurred, nothing but it becomes like whatever the surface area the size ingredients are coated on the yarn surface is becoming brittle, and because of this brittleness sometimes what will happen in the sizing operation itself, after drying, the warp sheet is going to pass through the splitting and through the lees rods, and it is going to wind into the beam. So in between these steps there may be chances of, because of the brittleness, this size film is going to be removed out from the yarn. So if it is removed, then there is no use of the application of sizing. As well as over drying is going to cause so many problems in the weaving zone, where sometimes what will happen in the weaving elements, if you observe the weaving elements, the warp sheet is going to be divided into two layers, and the warp sheet is going to pass into several mechanical parts, such as like heeled wires, reed ends. Now the metal to yarn abrasion is going to be occur. So if the metal to yarn abrasion is occur, so if the yarn is having brittleness, so the size film or size film which is there on the top side of the yarn surface is going to removed out in the weaving elements zone or in the weaving zone. So the droppings of the size paste is very problematic. So it is going to affect on the efficiency of the weaving machine. So in terms of breakages, the breakages of the weaving or warp ends are going to be more. Okay, so because the removal of the size paste on the from the yarn surface. So that is why we should require an optimal sizing application, optimal size pickup. Okay, optimal size pickup. This is the how the extent of drying has to be done. Okay, then the size yarn should not have more moisture than standard, because it has following disadvantage. If it is having more moisture content also, it is very problematic, because if more moisture is there, then it is very easy to attack by the mildew formation or any fungus or bacteria infections or bacterial attack on the warp sheet, because we are using the size ingredients, the natural ingredients we are using. So automatically it will be attracted the bacteria, so it loses the yarn strength also. Sometimes it is going to lose or it is going to affect, along with the size ingredients, the yarn properties are also going to affect. So insufficient drying may result in sticky beams also. So if it is not dried properly, so the warp sheet is winding into the beam, so layer by layer we are winding, so there may be chances of sticking of these ends in between the layers of beam is going to be occur. So that is why, so we required sufficient moisture content or in the present in the yarn. It should not be too high or it should not be too low. Okay, so these are the following drawbacks which are there if we have an excess amount of moisture content in the yarn. So we'll discuss here what are exactly the methods of drying is. What are exactly the methods of drying is. So generally there are three different methods of drying. One is called as a conduction method, second one is called as a convection method, and the third one is called as the radiation method. Okay, so we will see one after the other. First one is called as the conduction method of drying. So in this method, heat is transferred to the yarn through the metallic surfaces of steam heated cylinders. So nothing but there are bigger cylinders which are going to be hottened, or temperature is given with the help of steam. Okay, so because of the application of steam, the cylinder is going to be heated. So after heating, the warp sheet is going to be contacted on the surface of the cylinders, so that the temperature or heat is going to be transferred from the cylinder to the warp sheet, so that whatever the wetness present in the warp sheet is going to be evaporated. So this is going to be happen. This is the first method where exactly the conduction method of drying is. And now most of the cases and most of the bulk order MNC companies following the conduction method of drying process, because by considering all the economical issues and the versatility of the working of machine, by considering all the factors, we are selected that the conduction method is very useful and energy conservative method for the bulk order, that is the warp sheet drying process. So that is why the conduction method of drying is used generally in the industries. So now you can see that there are two cylinders, where the large cylinder and the small cylinder. So now we are passing the warp sheet through the Sow Box, and from the Sow Box the warp sheet is going to transferred into the large cylinder, and it is going to be contacted with the large cylinder, and the warp sheet is going to pass into the smaller cylinder. Now why we need to use two cylinders? Why not one cylinder we can use? Okay, so you just see that why we are using two cylinder, minimum two cylinders we are using, because the warp sheet which is passed above the cylinder 1. So now what is the contact in between the warp sheet and the cylinder is only one side of the yarn. Yarn is, assume yarn is circular. Yarn is circular. So the circular yarn which is going to be contacted at one side of the warp sheet. Okay, but what about the other side of the warp sheet? So that is why what we are doing is we are passing the warp sheet from the two cylinders. First cylinder will be dried at one side of the warp sheet, and the same warp sheet which is going to be passed above the second cylinder, so that in the second cylinder, second side of the warp sheet is going to be dried. Okay, so it is the case. So why we are using two cylinders is both the sides of warp sheet has to be dried. That is why we are using two cylinders to dry the warp sheet. So this is the thing, and if we have multi cylinders, no issue. So both the sides it will be effectively it will dry. Okay, so that is why I have shown the multi cylinder sizing machine or multi cylinders also. Okay, and we'll go to the second method, that is convection method of drying. Convection method of drying. In this method, hot air is transferred to dry the yarn. So nothing but there is a chamber, and inside the chamber we are creating the hot air. Nothing but the air becomes hot. Okay, so by means of steam or electrical heaters, we are heating the chamber. Here we are heating the chamber. Inside the chamber there is an air, so we are heating the air with the help of steam or electrical heaters. Okay, now what is and how it looks like, you can observe that. So the warp sheet is coming from the creel zone, and now this is going to be passed into the several rollers, because it should have some time, sufficient time to dry the warp sheet within the inside of the chamber. So if you are not just taking like through the heater or through the heating chamber, if you have taken, now you are not giving any time to dry the warp sheet, so it cannot be dried properly. So that is why we should have several rollers or several guide rollers inside the chamber of this heater, so that we are going to give sufficient time to the warp sheet to dry the warp sheet. Okay, then it will be going to deliver and it is going to send to the winding. So here in this case it requires more time and more energy in terms of like heating coils are required, more times the air has to heat. Okay, so the energy consumption in this case is very high. So that is why it is going to be used in specific cases like single end sizing machines. That too in different sizing machine, in different manufacturers. Some of the manufacturers, they are using the single end sizing machines with convection method of drying, and some of the sizing machines we have infrared, that is radiation method of drying system. Okay, so in the small quantities of warp yarns to dry, in that case we are going to prefer this case, that is convection method of sizing, convection method of drying. Okay, convection method of drying. And the third method, that is radiation method of drying. Now the radiation method nothing but the heat is transferred to the yarn by direct radiation. Okay, by the direct radiation. So what will happen? The energy is transferred to the yarn by electromagnetic radiation. So electromagnetic radiation we are using to heat the yarn or to evaporate the yarn. So the heat is going to be transferred to the yarn by means of electromagnetic radiation. Okay, so you can observe that this is one of the manufacturer, like CCI is one of the manufacturer, where they specifically optionally they are giving optionally, if you required, infrared element is going to be provided, so that the infrared rays or infrared the temperature heater is going to be provided within the machine, and we can use. And that too, in this particular case, as I told in the earlier, so convection method and radiation method of drying is preferably they are going to use for the small quantities like a single end sizing machines. So you can see that the single end sizing machine, this is called as a single end sizing machine, where we are going to keep one package, only one package, and this package is going to be, the yarn is going to be withdrawn from the package and will be transferred through the Sow Box, which is having small trough and immersion roller and squeezing roller, and the sized warp yarn is going to be passed in the chamber, inside the drying chamber. So inside the drying chamber we can have like a convection method of heating or radiation method of drying, so whatever it is. So after that the yarn is going to be wind into the cheese or cone which is there in the machine. So this is how the convection radiation method of drying can be done. Okay, so what are the three methods of drying? One is called as conduction method, convection method and radiation method. So most popularly for bulk orders and MNC companies, we are going to prefer and we are going to use is conduction method of drying. That is why we have discussed about 2-cylinder sizing machine and multi-cylinder sizing machine. So cylinders if we are using, nothing but it is like a conduction method of drying. Okay, now so finally in the sizing we will discuss what are the sizing faults. What are the sizing faults are going to be produced, and what are the causes and remedies for particular sizing faults are. So the faults should not be there. So we are discussing what are the different type of faults we are going to get and how we can overcome. We need to plan for that. What is the remedy to overcome that particular fault? So you can see that the first one is called as sizing spots. Sizing spots. Size material should be added gradually to the mixing tank for good mixing. So if it is added at once, or spots are going to be appear on the time. Nothing but if you have added completely like at a time, one time. So generally in the Sow Box we should maintain the size paste level. Okay. So if you are not maintain the size paste level, completely you are waited for the exhaustion of or completion of size paste in the size box, then what will happen? From the starting to the ending of the size paste, the add on into the sized warp sheet is going to be different. Now at the starting time the viscosity is different, and at the ending time of the paste maximum amount of water content from the size paste is going to be added into the warp sheet. So the viscosity is going to become more thicker, more viscous. So that is why what we should require is we need to add every time, we need to check the size paste level in the Sow Box. Okay, size paste level in the Sow Box, and we need to add a small amount of size paste into the Sow Box gradually. If you are not added like that, if you are added at a time all the things, then obviously you will get the size spots in the sized warp sheet. Then second fault is repeating warp streaks. Repeating warp streaks. This defect is due to uneven tension in the pre-beam. Pre-beam is nothing but warpers beams we are talking. If uneven tension is there, in that case we are going to get repeating warp sheet. Repeating. So 1 meter or 2 meter or half meter repeatedly, so the streaks are going to become. And the third one is the shinery effect. Shinery effect nothing but if you have maintained more friction or the contact between the rollers to the yarn, if you are maintained more, and if the yarn is slipped above the surfaces of rollers, then the size paste, after application of the size paste, it becomes a shinery. Okay, so it is going to influence the yarn drying also. Okay, then the fourth one is sandy warp. Sandy warp. So it is due to not crushed or grind the size material properly. If the size granules are not maintained proper granule diameter or the proper grinding, so the size granules will not be boiled perfectly within the time and temperature in the size cooking time. Okay, in the cooking time, this size granules, if the more size granules, generally more size granules require more time to boil. More time to boil and more time to gelatinize. The solid particles need to convert into solution or gel form. So this is, the conversion is called as gelatinization. So if you have granules more diameter, more size granule diameter, so it requires more time. If you are not given more time, these granules are going to become the same thing and it is going to looks like sandy warp. Sandy warp. So the roughness of the warp sheet is going to be increased. Okay, so it should not be there. So that is why the granule size is going to be maintained properly. So that is a thing. And there are few faults like ridge beams are there and hard sizing, improper drying. So drying will not be proper. So within the drying cylinders or within the drying zone, so that is the case. So it is improper drying nothing but still the wetness is there in the sized warp sheet. So it will be very easy to attack of the bacteria or any type of fungus. And size droppings are going to be occur if the warp sheet is over dried. Okay, and uneven sizing will be done if you are not control the speed and if you are not concentrated the size liquor viscosity or size liquor refractive index, if you are not maintained the size paste quality, then you will get this type of uneven sizing in the warp. Okay, so these are the different types of faults. So these faults should not be present. If it is there, then it is directly going to affect on the weaving process. So weaving process completely, the efficiency and breakages in the weaving is going to be increased. So finally you will not get the productivity in the weaving department. So these are the things related to the sizing machine and different zones in the sizing machine, and what are the methods of drying and what are the sizing faults is going to be occur in the sizing process. Okay, so this is how we are going to do the sizing. So we'll discuss in the next session what are the post sizing operations. Till then, thanks for listening. Bye.